I ended up analyzing a leg press machine, and I was going to show you how it works, but then I broke my foot. So instead, I'm just going to go back to my dorm room now and explain to you there.
Hi everyone, I'm Lauren Gabransky and I'm a bioengineering major, and as I said earlier, for my final project I analyzed the leg press machine at Epley. Growing up, I was always really involved in athletics and exercise, so I thought it'd be interesting to study the mechanics of this leg press machine. I also thought an analysis of this leg press machine could be useful and interesting because a lot of the information calculated can be applied to other pieces of exercise equipment. For Category 1, I decided to incorporate Unit 3 by constructing multiple free body diagrams of various portions of the leg press machine. In doing this, I needed to incorporate various forces from rollers, fixed supports, and other components. This information helped me to then move on to my analysis of Unit 5, 2D rigid body equilibrium. As I solved for the minimum required force that a user of a machine would have to exert to lift 200 pounds with the cable system. By summing the forces in both the x and y directions, I was able to determine that the force needed would be 275.8 pounds. Moving into Category 2, I decided to look at Unit 7, stress and strain, and Unit 8, material properties, as they related to the cable portion of the machine. I calculated the stress, strain, and change in diameter of the cable with various weights being lifted. I also calculated the safety factor of the cable when 410 pounds of weight were being lifted because this was the greatest weight in the column. Finally, I calculated the maximum force of weight that the cable was capable of withstanding before deformation occurred. As you can see in my calculations, I solved for the normal stress at various weights by dividing the normal force by the cross-sectional area, which I then divided by Young's modulus of 27.6 times 10 to the 6 psi to find the tensile strain. Next, I manipulated the equation for Poisson's ratio, which allowed me to find the change in diameter. These values could be useful for engineers and equipment manufacturers when looking at the impact that various weights will have on the quality of the cable over time. Next, I moved on to calculating the design normal stress of the cable when 410 pounds of weight were being lifted, which I found to be 102.42 megapascals. By dividing this value by the known max normal stress of the cable, which is 506 megapascals, I found the cable to have a minimum safety factor of 4.94. This information should be reassuring to users and owners of the leg press machine, since the cable is designed to support nearly 5 times the maximum strength it is expected to endure, meaning it's pretty unlikely the cable will fail under normal conditions. In the final portion of my project, I calculated that the maximum weight that the cable in the leg press could experience was 2,026 pounds. This was very interesting to learn, especially since that's basically like lifting 1,147 basketballs, or 70 bicycles, or 2 to 3 zebras.